All right, everyone. Welcome to our first, actually, you don't know this is probably our second video recording of Data Science Imposters. Jordy, Antonio.
Hey, what's up? You
We're
saw you saw how I made my voice deeper, right? Like it's
well, you want people to now associate your voice with
you know.
deepness. How you doing, man?
Good. We should have done this earlier.
Yeah, we're excited to try this means of communicating with you guys. There are many topics we've wanted to cover, but we've always thought, well, just audio of it would be kind of tough, tough to get through.
Yeah.
So we're gonna do something different today.
Yeah. So I'm excited because one of my coworkers brought this to my attention. I had never heard of it. It's called Anscombe's Quartet, and I'm probably mispronouncing that. It's on the page here, Anscombe's Quartet. And really what it illustrates is it's a good point. It's a good point about data visualization. It illustrates something really important, which is that with data and visualizing it, you get so much more and so quickly, and you can see some interesting information. But Anscombe's Quartet describes Quartet being four. It describes four data sets, right? And if you look at the data sets, only using some, statistics methods like the mean, the variance, sample variance, the mean of y, the sample variance of y, correlation between x and y, the linear regression, and the coefficient of determination. All of these, for these four data sets, are pretty much the same or
Yeah.
within a certain accuracy of each other.
Yeah, within 3 decimal places, which is, I mean, that's pretty accurate.
Right, that's 3 decimal places for some are 2 decimal places, and
Mm-hmm.
some are exact, right? Like
Mm-hmm.
the mean and of x and sample variance of x. But if you look over here on the right-hand side, right, you see, like you can
That's
tell,
that's crazy.
right? There's no denying it. And we always talk about how like the data analytics and doing that, describing your data with some of these methods, it's supposed to give you a better idea of that data. But we see now that like visualizing it gives you even more because you can tell that those four data sets are not the same.
So for the younger folks watching, the orange points are literally plotting the graph of your values, and then the purple or blue line is the linear regression line. And as you can see, that line is identical in all four different data sets. And you wouldn't have known that, to Antonio's point, if you wouldn't have visualized it and plotted it. Because if you would have just looked at the data, the mean and the variances, you would have just said, oh, these are all the same.
And Jordy's saying for you younger guys only because I think he's going to the point that in math, when we learned this in math, you don't see this until much later in,
That's
I
what I
think
meant.
it's
Yeah.
course two for New York Staters when we start plotting stuff. I don't know if it's course one or course two. So that's either 9th or 10th grade for most people,
Yeah.
right? So, but we can see that vast difference, and so this is pretty interesting. All right, this is from 1973, which I found interesting that I had never heard of it. So I said, all right, well, look, I'd love to like try to recreate this. I'd love to like make sure that these numbers are right, and I'd love to like introduce you, Jordy, to, you know, um, to how I would look at this in Python.
Ooh, am I going to see Python for the first time today?
I hope not. I hope you've seen Python already. You've been on this podcast for 4 years, so I'm hoping that you have. So let's
As an
just
imposter.
jump. Let me
As an
just jump
imposter.
into Collab. We're gonna use a notebook, and we're gonna use the Google notebook, and that's at collab.research.google.com. And I'm just gonna make a new notebook. Jordy's first
Python
Python
sesh.
notebook.
Nice.
uh, okay, so in this notebook, basically I can write Python code. I can also write, I can add text and just describe things a little bit. So I'm probably going to need pandas as PD, and pandas is a package that we use in Python. I'm probably going to need numpy, and usually you abbreviate that with MP. Those are just standards that people use.
Mm-hmm.
If I press Control Enter, it'll run that code. I forget if Alt Enter gives me a new one. Okay, great. So the first thing I'll do is they actually include the data set at the bottom here.
Mm-hmm.
So I can take this data set, right? And I can pump that data set right in there, right? And I see that I can actually, this is X, this is Y, this is X, this is Y, this is X, this is Y, this is X, this is Y.
Mm-hmm.
And I can I can just basically make this what we call a tuple, right? So there's two items here. So I can make that a tuple, that's my X, Y. And then I can make this a tuple. So I can make that my X and Y. And then that's a tuple, right? That's X and Y. So
What
I'm
phrase are you saying? You're saying tuple?
tuple. It's basically just a pair,
Okay.
right? But so this is my first line, so I'll make that into an array there, and then I'll follow that same pattern all the way down.
Nice.
Okay, and so with the power of video and magic, that's how it ends up looking. Now I don't. So basically, in this case, if we look at what we've created, you know, like we have 1, 2, 3, 10 rows, right? And
Mm-hmm.
each row has you know, four pairs, right? X and Y, X and Y, X and Y. But I don't really think like this, right? I want sort of it's 4 data sets, right? Remember, it's 4 data.
Yes, 4 data sets.
1,
One,
2,
two.
3, 4, right?
Mm-hmm.
So I think of like how I think in my brain is I like to have my data set like all in one row,
Okay.
right? So what I have to do is I can just rotate this. So if I think about my first data set being this one, this one, this one, this, all these items together, that would be my data set.
Because they're in columns right now.
Right. Right now they're in columns. I would just want to flip them over to, you know, to make them into
Rows.
rows. Right. And so how I do that is I can basically do phases equals np. So numpy dot rotate 90 degrees values. And I'll, oh, what happened there? Oh, okay, just went to the bottom. And if I just type phases at the bottom here, it'll actually print out what that would result in. And you see it's exactly what I want, right? It's now I have 4, you know, I have like 4 rows and each row has 10 columns. And these are the columns here. That is exactly what I would expect. And if I look at this, it's actually giving me the first row, the 4th row last. Doesn't matter the order for me. But so that's 8, X is 8, Y is 6.58. And the last one is X is 8 and Y is 6.89. And I look at that 8 and 6.89. Okay.
6.58. Perfect.
So that's the data. Right. So now we talked about a couple of different items here. So mean of X, right? The average of those values, mean of Y. So let's do that. Okay. So the easiest way for me to do this is to basically do a loop of, so basically I can look at one row at a time and calculate that information one row at a time.
Okay.
So I can do for I in range of 4. So basically I'll go from 0 to 4, not including 4. And then I can access each of these items like that. So let's see. So I can get the.
You mean 0 being the first integer, let's call it. So 0 is 1, 1 is 2, 2 is 3, 3 is 4. Don't go past 4.
Right, exactly.
Don't do this
right?
4 times. Yeah.
Yep, for arrays and in computer science, a lot of times we'll start with 0 index, 0 being the first item here. So we have
Index.
0
Okay.
index, 1 index, 2 index, 3 index.
Got it.
There's 4 items, right?
Mm-hmm.
All right, so to get the average, we can use a function called numpy average. And what I'm doing here is I'm saying phases I, right? So my ith row, and then give me all of the x's, right? And this is essentially how I do that, right?
0 is X.
0 is x and 1 is y.
Okay.
Yep. And so if I put that there, I will see 9, 7.5, 9, 7.5, 9, 7.5. Okay, so that is my mean, right? So that's
9 and 7.5.
yep.
Mean of X is 9. Mean of Y is 7.5.
Yep, pretty straightforward, right?
Mm-hmm.
That's not and I can do basically the same thing for the sample variance, and I will actually put the average and then the sample variance.
Of each X and Y.
Yeah, a piece. And look, we can calculate these items ourselves, right? Like we can do this ourselves, but we're not going to do it if there's functions built in. And numpy has the variance function built in, and if we just hover over it, it'll tell us exactly what it's doing. And DDOF1, right? So if we go here, you'll see, and you can probably scroll down, and it's the delta degrees of freedom, right? The default here is 0. Most people expect that for variance, for sample variance, you would actually have the default to be 1. NumPy uses 0 for like sort of the population variance. So that's one change that you have to do there. And that's the divisor when you're doing variance. Yeah, we're not going to go into that. Basically, you set that to 1 here because we're dealing with a sample population. Okay, and so the quartets are actually numbered differently. I think so. Actually, they should be like opposite. 3 is actually my 0th item here.
Here's 1.
Yeah, and I won't go go too crazy about that. But what I'm looking at is the values, right? I'm looking at these values to make sure it makes sense, right? Sample variance 11.
11.
Sample variance over here 4.125.
125.
And that's 1.27, 1.2, 1.23, and they say plus or minus 0.003, which sounds about right.
Sounds about right.
Yep. Cool. That's 0.03. Yep.
Yep. Minus 3. Yep. Minus 2.
So I know this part over here is tricky with the phases, and I might review that at the end if we have time. But basically, I'm just accessing the information that I need for this one.
You already set up what phases is, right? You did it up top, so you just write the word phases.
I did, but like getting this is a bit confusing sometimes, because basically I'm saying this is like my, for instance, if I'm talking about the 0th row, I'm gonna get this one, right? And then and then what I'm doing is I'm getting
only the X's
all
in
of
there.
these, but all of these, that's what this colon stands for. It says get all of these items within here, right? Because within my 0th row, I have 10 tuples or 10 pairs of items.
Okay.
And I'm saying get all of them, and for all of those, just get me the 0th item in there, so, which is X in this case. Yeah. I know it's a little bit confusing. I know it's
no,
one
0
of those,
being the first position.
Yeah, if we had 3 items, we could go 0, 1, and 2, right?
2.
Yeah.
Got it.
So all right, so those were easy, right? Like 4.
Yeah, we 4 out of the 7.
I mean, correlation is going to be the same thing, right? We're just going to basically say, and I have to remember, so correlation is just this one. What we're going to do here
Okay.
is the Pearson product moment correlation coefficients. And so it's core, COEF, and numpy also provides that. So I'm getting the correlation between those. So now I want to show you something because I get the correlation and then I access the information in the correlation. So before I get that, let me take out that 0 and 1 here, right? Let me just take that out for a moment to see what that returns. Yeah, so the correlation gives me some other information. And so I'm just stripping out the other information and just getting the value that we care about, which is 0.1865. That's what I'm doing there. And if we look at it, it also gives us R, which is the correlation coefficient matrix, okay? And we're just ignoring that. It ranges from -1 to 1. It's not something we're looking at in this case. So that's there. And is that in line? The
8.816. There it is.
Awesome. Awesome. What's next? What's next? Linear regression.
Linear regression.
Okay. Yeah, we have to get linear regression before we get the coefficient of determination, right? Now you remember what a linear regression is. It's drawn here, right? It's that line that fits the point, right? Sort of to the best ability, right? So that it, sort of goes through the points, minimizing sort of the error that you would otherwise get, right? So that's what that line looks like. And how will we do this? Okay, so this one we are actually going to use our friend numpy again. Okay, so they have the linear polyfit, least squares polynomial fit a polynomial. And so if I run that, okay, the polynomial fit between x and y of Quartet is 3.0 plus 0.499x, right? Right. And so we remember a regression line has the slope, right?
Nice.
And has the intercept, right? And does that match?
0.5x.
0.5x, 2 and 3 places respectively.
That's
great.
Pretty good.
So 3, 3, 3, 0.5, 0.5, 0.49, and 0.49. Awesome. Awesome. Now, coefficient of determination, R squared. So
the proportion of the variance independent variable that is predictable from the independent variables.
Right. So in order to get the R squared, right, you actually have to look at you have to look at your linear line, right? And you basically have to say for each x, what would my linear regression produce? Right.
What would my y be? Predicting the next value is what you're saying.
Right. Yeah. Exactly. Okay. So how will we do that? Like how we have this linear fit here. How could we get the we have the intercept is here.
Oh, you gave the hold on. So you gave the linear regression line. You've identified it to be linear fit. So now whenever you write linear fit in the code, it'll know to be the polyfit, right?
So yeah, so it already gave me what the linear regression is. It gave me the formula, right? So it said 3 plus.
No, I know, but you'll never have to write. You never have to do that whole code again. You can just write linear fit going forward.
Yeah, exactly. So what I can do is I can actually create a value called predicted y's, right? And so my predicted y's is actually my linear fit, right?
Nice.
And that is my linear fit x, right? So that's 0 times, right? So that's times, oh,
0.5, right?
No, so that's times all of the zeros, right? So how do we write all of the zeros within this row?
Oh yeah. Okay,
How do
I
we
see where you're
write
going.
all the zeros within this row, right? So that's phases I gives me all of the items in this row, right? X and Y. And then I want all of those items
Comma 0, right?
comma 0, right? So that's going to basically multiply the single value 0.5 times all of those items. And then if we wanted to just be like, just sticklers for, we can also then add my intercept, my y-intercept, and that would be, come on. No, that's wrong. I took my eye off the ball there. Okay, so my y-intercept is my linear fit number 1, right? That's what we have printed over here. Yeah, number 1. Okay, great. So that's my predicted y's, right? So yeah, like we can now we can determine the R score. But like I'm a developer, I'm lazy. I'm not gonna do like my own determining. So let's use scikit-learn. They have R2 score. So I could just call that function. And I just have to pass it in the actual y value, right? Which again we talked is that, and then our predicted y's. Right, and then print R2 score for model is R2. Okay, and let's see what we get. 0.6666666. Is that right? Awesome. 0.67 to 2 decimal places. Right, 0.67, 0.67, 0.67, and these are all using the right information there.
This is like a different language. This is cool.
It's not English.
It is not.
but it's not what they try to make you learn at RPI. I think you had to learn C, right?
I learned C, yeah. Well, excuse me. I took a C course and I passed it. Didn't learn anything.
So we all right, so we can stop there, but that is only half. So we agree that this is the right thing. But how would you plot this thing, right? Like how would we actually plot this? So let's take a look. And so there's a couple of different ways to plot it, and we're gonna do the plot, right? So the great thing about the loops and all this is that like I can just do it here, right? Like I do it once and it just runs it for everything. So I can actually make I haven't used my data frames yet. So I've used numpy, but I haven't used my pandas data frame. So data frame is sort of like a table in SQL or like a Excel sheet. It's a more robust like right now we're using a 2D array, and a data frame can wrap around that 2D array and like give you more functions, sort of for free or built in to that. So all we would have to do is say phases equals pd dot data frame, right? And then the data is equal to just phases I, and then I can actually give it columns. I think that's X and that's Y, okay? And I'll tell you why I'm doing that in 1 second. The reason I'm doing that is because there is a very, and I'm just looking at my notes here. Oh, there's a very simple way to plot this, okay? And with the data frame, like it's so, I don't do this enough, but it's so simple. So that should, unless I did something wrong, that should give me some options there. Sometimes it just doesn't like it. Scatter. X equals X, Y equals Y. Just because I named my values that. Okay, cool. So, okay, so this is giving me the scatter, right? So if we went back and we looked at it, we would see that this should be the last one. Yep. This is that one. This is that one. This is that one. This is a scatter plot.
It's important to note though, that the x-axis for everything begins at 4, except that first one starts at 8 for some reason. It's still right. It's still 100% accurate, but
yeah. So one of the things with just using the default here is that it's not gonna represent the data how you want it. So this is great. You can actually add more to it, but I didn't find a way to do a linear regression on top of that.
I got you. No, it went to that first value. This is the first area that's populated. That's what I'm. Yeah.
Yeah, but I wasn't able to create that. So then I did a little Googling, and I remember there's a library which looks pretty cool, and it's called Seaborn. Okay, and so Seaborn is a great visualization, and I could put my import wherever I want. I could bring it to the top, but just to show you, I'll just put it right here. And then, so I'm going to use
A little bit of formatting discipline there.
Yeah, you can bring it to the top. Some people like to see everything up there. Some people like to see, it
when
depends
it
what you're doing it. Yeah, some people like to see when it happens. You don't want to put it in a for loop because it's just going to import it. It won't import it 4 times, but it's just an unnecessary thing. So I left it out of the for loop.
I get it. No, you don't want to drag this thing down either.
Yeah. So we're going to take out the scatter, right? So that's a scatter plot, right? X and Y. That's what we, that's how we would represent something like that. So here we're going to do, for seaborn, we're going to do linear plot. And so very pretty, right?
Yes, you did it.
Yeah. So seaborn does do this plot. And it,
what's that? What's the blue? What's the baby blue cone?
Right. You know what? I couldn't understand what that was, and I couldn't take it out. And I was like, this sort of like destroys the analysis. It sort of like shows that it's actually different, right? Like, but that's what the visualization is for. It makes sense. It is showing it, but I couldn't understand what that was.
It looks like it's range of error, right? Because it goes closest to the.
Yeah, it looks like it's related to that in some way. Although if that were the case, like this is spot on right here, right? You see, like, and it's sort of curving away from that. So I wasn't too sure what that was. So I said,
true. That's true.
You know what? Let's go to the most basic approach.
Okay.
So that we already talked about 2 ways to plot your
it.
Yeah, and very, very simple, very straightforward. It does get harder once you like want to try things. Like it always gets harder. So the third one we're gonna do is we're just gonna do that. So we can use PLT, which is matplot. Okay. So you remember?
MATLAB.
Yep.
I remember MATLAB.
I think it's related to MATLAB in some way and how it does plotting.
It's very
I may be
mathematical.
wrong, so don't quote me on this. Don't put this on video. Don't put this on YouTube.
It's going. It's going.
um, and then the last thing I want to do here is I want to actually square those things away, right? So I'm actually going to set the X and Y axes there, and then I'm going to say show. And so I basically, I'm drawing my plot, okay? I'm creating my
The space.
scatter
Mm-hmm.
of my X and my Ys. Coloring it, I'm actually then plotting another line, and that line is my X's and then my predicted Ys. And I'm gonna color that red. And then I'm gonna set my X a limit, right? So my X and then my Y limit, and then I'm gonna show, and that's it. So cool. So I see, I see the data here, see the data there, see the data there. And I thought that was pretty cool. And I was like,
That's pretty dope.
you know what? There's one thing that's missing. And I was like, I can't just stop here. Like, I want to see just how they have the 4 charts. I want to see it in four things together. I don't want to have to scroll.
How did Wikipedia do it?
So then I remembered this. I had to Google how to do it, but I remember you can do subplots, right? So what I can do is I can actually say that I'm going to have subplots. So I'm going to have 4 plots, right? And each of them is going to be represented differently. So let's go ahead and do that now. So, okay, where is that? I hope I saved that. Yep, there it is. So, and that, so you have to do things slightly differently. But basically, this is sort of the syntax for doing it. I'm determining the row and the column here. I want to know where to put my first thing, my second thing, my third thing, based on the row and column. So that's a little bit weird there. Don't worry too much about it. But what I'm doing is I'm doing the scatter again, and then I'm doing a plot, just like I did before, just like I did right up here. Scatter and plot. I set my axes right there. And then I'm just doing a 2x2. So four plots. Whoa, I got more than 4 plots because
you looped the loop.
I looped it, huh? I looped it. Yep. So I don't want to have that part in my loop. See, Jordy, loops will get you, man.
I'll get you, baby.
Let's see if we got it right this time.
There
Awesome. Awesome.
What?
Now I can say I'm proud of that. Like now that feels pretty good.
We proved a lot of things today, Antonio.
So yeah, I mean I didn't prove anything. It was just it was an idea. I don't think it's a great thought exercise and thought problem. I don't think many people are going through this, but there's a couple of things to take away from this, right? And we can see that information directly from the visualization. One of them is that one of the reasons why the linear regression is the same for these is because of outliers. like outliers really like throwing off the data,
Hmm.
right? And so that's one thing to like be careful about, especially like this top one
That
here.
one, that's the
This
one that
one,
has the
it
most
has,
aggressive one. Yeah.
yeah, it has a lot of it has one outlier that sort of throws everything else off, and it's like the most, it's like the most convincing evidence there.
Hmm.
um when you're doing this, you're doing the squared error, like you're, because this is above it and this is below it, you sort
It
of get,
averages out.
it averages out.
Hmm.
Yeah. So it's important to visualize your data. It's important to know your data. um um what do you take from this?
A couple themes that we've said on the show, if you've been listening to the show long enough, is that one, we learned about this phenomenon, let's call it, this quartet, right? With this sample data set, you were able to go on here, use numpy, practice your skills, right? Plot it out yourself, prove it yourself, and and just do it, right? And how many things on Wikipedia are proven to be incorrect? Quite a few. And so, like, oh, let's see if this is a real thing. This is a real thing. You
Oh,
can,
that's actually pretty. That's actually a really good point. I hadn't thought about. There was an article. What was it? 2, 3 years ago, maybe even more. Someone had written a paper about how most of the papers that they had read they couldn't reproduce,
yeah,
right? And
yeah.
so, yeah, and well, because the data had. Imagine if you had
It's
a
public. You
paper
could
like,
write it in.
and like, imagine if you had this paper and the author didn't provide the data,
Correct.
right? Like you like, wait, I don't, like you can maybe like get it and figure it out. And some people have been able to generate additional data sets that sort of follow the same similar theme.
Hmm.
But yeah, you're right. Like it's nice to have the data, nice to reproduce it. And along the way, you might learn something new.
Hone your skills. And what's the whole point of the scientific method? If you can't reproduce it, then it's not real, right? So this,
Wow.
I thought that was cool.
Awesome. Awesome. All right. Well, that's it for today.
I think for our first rodeo on the video realm, that was very good. Thanks for walking us through that. It was awesome.
Okay, sounds good. And if you are just watching us now on YouTube or wherever we may land, we do have a podcast. If you just like listening, or if you're going to start your commute soon because your job is sending you back to work, um, uh, check us out, Data Science Imposters.
See you guys soon.